All right, everybody. I'm Walker Ridgway,
And I'm Andrew Kelleher.
and we did the Project 3 Hydraul box measurement solution. The goal of this was to get real-time measurements of a box going through the conveyor using distance sensors. If you'll follow me over here, I'll show you kind of what we used and give you a breakdown of our ladder logic. So we used 4 Allen Bradley distance sensors, a bailiff barcode reader, and a pneumatic diverter with 2 trigger photo eyes. A breakdown of the logic is you have the anti-tie down that you have to hold for both buttons for 1 second, which triggers the horn for 3 seconds. After that's done, the conveyor will come on. Put the box on, it will get here, this trigger gets activated, and it will attempt to straighten the box. When it straightens, it will go through, and the sensors right here, the black sensors, are activated anytime this trigger is activated. And so it will be getting measurements, and as soon as it's past the trigger, it will end, and it will keep those measurements up until it is done. The sensors are in millimeters, so we had to convert them to inches using division in the ladder logic. Yeah, that's essentially all I need to say for right now. I'll let Andrew explain the HMI.
The HMI is where, if you follow me over here, the HMI is where all of the statistics are going to be shown. So the measurements of the box will be shown, a count for how many boxes have gone through total, as well as the count for how many small, medium, or large boxes are gone through. The operation of the Hydraul conveyor is also shown here, as well as a small diagram of the conveyor layout, just so you can sort of get an idea of the shape of it all. There is also a calibration option, which we will demonstrate later. And in order to demonstrate, we're just going to start it up. Hold both buttons on each side for 1 second. Box will go through. It will attempt to be straightened, and through there is where it will be measured. We'll send a couple more through just so you can see it. That one went a lot straighter. And if you want to take a look at the HMI when this next one goes through, you can see, didn't read the barcode on that one because it went through sideways. This one will go through. It'll attempt to be straightened. You'll see the measurements here, and you'll probably notice immediately that they're not quite right, because that box is very likely not 60 or 0.63 inches, which is where calibration comes in. So I'll stop the conveyor for a second. We will put a box that we know the dimensions of into the reader here. We know that this box is 6.5 inches in every way. Could you hold this, please? Meaning we can come over to the HMI, and you'll see these numbers updating in real time. If we hit the measurement calibration button, we can then input the value to subtract the final distance from in millimeters here. So we need to tweak this number until we see 6.5 inches roughly in the length section. So I think it was, let's try 2150 real quick. All right, went the wrong direction. Let's try 2550. Okay, we're getting a little closer. You get the general idea. So we'll say 2450. Get us around there. Of course, I'm fiddling with all this, but ideally you would only want to set this up one time. Okay, we're about closer, but idea is you can go into measurement calibration, which is open, and calibrate until you know that your distance sensors are reading the right measurements. And then those are summed up into a volume equation to dictate whether they are a small, medium, or large box. So if I were to take this one out, and this is ideally, given that you're getting the right measurements, it would count as a large box. So you see that one went up 1. And I will pass it back over to Walker to explain the rest.
So I guess one thing I want to add is the toughest part of this was getting the pneumatic diverter to straighten out our boxes correctly with this bend in the conveyor. In an ideal world, we want angled rollers, but obviously that is not a solution here. So that was probably our hardest aspect of getting this thing working, because if the boxes come through crooked, you're going to get wrong measurements.
Talk about the other way we could have done distance.
Yeah, so one way you can do distance is if you have an encoder and you know the speed of the belt, you can go off how long a photo eye is triggered in order to get the length of it. So we had to use 2 link sensors here, and we had to add up the links total out of each one and then subtract it from a centralized number, which is the number we are doing in calibration. That's what we are changing. Yeah, if you have an encoder, you're able to do it off one photo eye. So I think that's it.
That's about it.
Yep.
Thank you so much.
Any questions?